Stop the installation. Close the terminal. Step away from the USB drive. Because what you are about to do, what you have probably already done 3 or 4 or 7 times on different machines with different distributions and different partition schemes and different desktop environments whose names you researched and compared and debated on Reddit threads before making the selection that felt like the right one. What you're doing right now, at this moment, on this machine, with this distribution whose download you queued and whose installation guide you have open in the browser tab next to this one, is the thing that experienced Linux developers watch new users do and recognize immediately as the pattern whose repetition is why the same person reinstalls Linux 6 times in a year and never builds the productive workflow that the platform is supposed to deliver, never reaches the configuration, stability that makes the daily experience of using Linux the experience of working in an environment that works for you, rather than the experience of managing an environment that is constantly surprising you with the consequences of decisions whose implications you did not understand when you made them during the installation process, that felt fast and clean and like you were making the right choices because the installer presented them in the language of simplicity and the checkboxes had defaults that felt sensible, and the partitions were configured automatically. And the desktop environment was selected based on which one looked best in the screenshot you found on a forum post from 3 years ago, rather than based on the understanding of what each choice would mean for the workflow you're trying to build on top of the system you are installing. This is the warning that nobody gives you before the first installation. This is the information that the distribution wikis assume you already have. This is the conversation that the Linux community has with itself in the intermediate and advanced spaces where the beginners do not yet have the access that comes from knowing enough to know what questions to ask. The conversation about the installation decisions that look identical at the moment they are made, and whose differences only appear weeks or months later in the form of the problems that the wrong decision plants in your system at installation time, and that the right decision would have prevented before the system was ever live. You are about to install Linux the way most people install Linux, which is the way that creates the most problems, generates the most reinstalls, and produces the most developer frustration in the first 3 months of Linux use. And this warning exists to interrupt that pattern before the installation runs, before the partition table is written, before the bootloader is configured, before the decisions that feel like minor installer wizard, choices lock in the consequences that you will be living with for as long as the installation survives. The first thing you are doing wrong is choosing your distribution based on popularity rankings and forum recommendations rather than based on the specific alignment between the distribution's design philosophy and the specific use case that defines your actual daily workflow on Linux. The distribution rankings that appear on DistroWatch and the recommendation threads that dominate Linux subreddits represent the aggregate preferences of a population of Linux users whose diversity of use cases means that the most recommended distribution is the most recommended distribution for the average of those use cases rather than for your specific case. And the distance between the average case and your specific case is the distance between the distribution that the recommendations point you toward and the distribution that your workflow actually requires. Ubuntu is recommended constantly and correctly for the general use case of someone who is new to Linux, wants a stable and widely supported environment, and values the large community and extensive documentation that Ubuntu's dominant market position has produced. But Ubuntu's stability model, whose foundation is the long-term support release cycle that prioritizes stability over the currency of available packages, is the model that produces the package versions that are months or years behind the current releases of the development tools that active developers need current versions of, meaning that the developer who installs Ubuntu LTS because Ubuntu is the recommended distribution and then discovers that the version of Node.js or Python or Go or Rust in Ubuntu's package repositories is significantly older than the version their project requires, is the developer whose distribution recommendation was correct for the average case and wrong for their specific case, and whose solution, adding third-party PPAs using version managers like NVM or PyEnv, compiling from source, is the solution of someone working around a mismatch between their distribution's design philosophy and their actual requirements. A mismatch that a better initial distribution choice would have eliminated. Fedora, whose design philosophy centers on shipping current versions of software quickly while maintaining a stability standard that makes it suitable for daily use, is the distribution that many working developers find better aligned with their actual workflow requirements than Ubuntu. Not because Fedora is better than Ubuntu in an absolute sense, but because Fedora's currency model matches the developer use case more closely than Ubuntu's stability model does. Arch Linux, whose rolling release model ships packages as soon as they are available, and whose installation process requires the understanding of the system that the installation itself teaches, is the distribution that developers who want complete control over every component of their system and who are willing to invest the learning that control requires find most aligned with their requirements. The distribution choice is not a brand loyalty decision. It is an alignment decision whose correctness depends on understanding what you need from the distribution and choosing the one whose design philosophy was built around providing it. The second thing you're doing wrong is letting the installer partition your drive automatically without understanding what the automatic partitioning is creating, what the created partitions contain, and why the partition scheme that the automatic configuration produces may not be the partition scheme that your usage patterns require. The automatic partitioning that most Linux installers offer as the simple installation option creates a partition scheme that works for the median use case in the way that median solutions work, adequately for the center of the distribution and poorly for the edges, and the developer use case with its large, long-age runtime installations, its growing Docker image collections, its compilation caches, its virtual environment directories, and its project repositories whose combined size grows continuously as the development work accumulates, is a use case that sits at the edge of what the automatic partition scheme accommodates before space problems. In-specific partitions begin constraining the workflow. The most consequential partitioning decision that the automatic installer makes without asking your input is the decision to place everything on a single root partition, or, in some distributions, to create a modest home partition alongside the root partition. A scheme that feels clean and simple at installation time, and that reveals its limitations the first time a package installation fills the root partition, because the root partition's allocation did not anticipate the size of the package caches, the language runtime directories, and the system-level application data that accumulates in root-owned directories during active development work. The separate home partition is not the only partitioning consideration that the installer's automatic configuration handles without your input in ways whose consequences matter for developer workflows. The swap partition, whose size the automatic installer determines based on a formula that was designed for general use cases rather than for the memory pressure profiles of compilation, virtualization, and container workloads, requires explicit sizing decisions from developers whose work creates memory pressure patterns that the formula does not anticipate. The boot partition, whose size the installer allocates, must accommodate the kernel versions that accumulate over time, as system updates install new kernels without removing old ones, and whose inadequate allocation produces the boot partition full error that requires manual kernel cleanup before the next update can proceed. Understand the partition scheme before you accept the installer's default. Know what goes in root, what goes in home, what the swap is for, and how much space each partition requires for the work you actually do. The third thing you are doing wrong is installing the full desktop environment suite without understanding what a full desktop environment installation puts on your system, how much of it you will actually use, how much of it runs in the background consuming the memory and CPU that your development tools need, and how the desktop environment's system integration affects the behavior of the development tools that operate alongside it. A full GNOME installation, which is the desktop environment that Ubuntu ships as its default and that many new Linux users install because GNOME is what they see in the screenshots and the YouTube videos, installs not only the GNOME desktop shell, but the entire GNOME application ecosystem. The GNOME file manager, the GNOME text editor, the GNOME terminal, the GNOME system monitor, the GNOME software center, the GNOME settings application, and dozens of other GNOME applications and background services whose presence on the system represents memory consumption, background process overhead, and system resource competition that affects the performance of the development tools running alongside them on hardware that has a fixed amount of RAM to distribute across the system processes that are competing for it. The developer who installs a full GNOME environment on a machine with 8 gigabytes of RAM and then runs a development server, a Docker container, a browser with the documentation tabs, and a code editor simultaneously is the developer who experiences the memory pressure that turns compilation into a slow process and container startup into a waiting exercise. Memory pressure that is partially a function of the hardware's limitations and partially a function of the desktop environment's background resource consumption that a lighter desktop environment would not generate. XFCE and i3 and Sway and other lightweight or tiling window managers represent the alternative desktop environment choices whose lower background resource consumption leaves more of the system's available memory for the development tools that the workflow actually requires. Choices that require more initial configuration investment than a full GNOME or KDE installation. But whose return on that investment is the system responsiveness that the full desktop environment's background overhead was preventing? The desktop environment choice is a resource allocation decision whose consequences appear in the performance of every development tool that runs alongside it for as long as the installation is live. The fourth thing you're doing wrong is skipping the post-installation configuration steps that transform a fresh Linux installation from a generic operating system into a development environment. Skipping them not because you decided they were unnecessary, but because the installation guide you followed ended at the point where the desktop loaded and the browser opened, and the system felt functional enough to begin work before the configuration that makes the system actually configured for development work, rather than merely operational for general computing, had been applied. The fresh Linux installation is the foundation. It is not the house. The post-installation configuration, whose steps the installation guide skipped, is the construction of the house on top of the foundation. The installation of the development tools and the configuration of the shell environment, and the setup of the version control credentials, and the installation of the terminal multiplexer and the configuration of the dot files, and the firewall rules, and the SSH configuration, and the system performance tuning, and the dozens of other configuration decisions, whose application to the fresh installation is the work that produces the development environment rather than merely the operating system. Developers who skip the post-installation configuration and begin development work on the unconfigured fresh installation are developers who are building their workflow on the generic substrate rather than on the personalized environment, who are missing the shell aliases that would save them repeated typing, who are missing the Git configuration that would make their commits correctly attributed, who are missing the firewall rules that would protect the services their development work exposes on local network interfaces, who are missing the performance tuning that would make the system's memory management behavior better suited to the memory pressure profiles of development workloads. The post-installation configuration is not optional. It is the second half of the installation, whose first half the installer wizard completed, and whose second half no installer wizard will complete for you because its content is specific to your workflow rather than generic to all Linux users. The fifth thing you are doing wrong is not understanding the boot process and the bootloader configuration, whose misunderstanding is the source of the boot failures, the dual boot conflicts, the missing operating system errors, and the unbootable system situations that generate the Linux forum posts, whose volume reflects the frequency with which developers encounter boot configuration problems, whose resolution requires the understanding of grub and UEFI, and secure boot and the EFI system partition, that the installation guides explain at the level of the specific steps required to make the installation work without providing the conceptual understanding of why those steps are required and what they are doing to the system's boot infrastructure when they execute. Grub, the Grand Unified Bootloader, is the software that runs before the operating system, and whose job is to find the kernel, load it into memory, and pass control to it. The software whose configuration file determines which operating systems are available at boot, in what order they appear, which one boots by default, after how many seconds, and what kernel parameters are passed to each boot option. The developer who installs Linux and dual boot with Windows without understanding grub's role in managing who interprets the missing Linux option as evidence that the Linux installation is gone, rather than evidence that the bootloader that was pointing to the Linux installation has been replaced by one that does not know it exists. UEFI Secure Boot is the firmware security feature that prevents unsigned bootloaders from executing during the boot process, whose interaction with Linux bootloaders requires either the disabling of Secure Boot in the UEFI firmware settings, or the use of a signed Linux bootloader whose signature the UEFI firmware accepts. A requirement whose existence is the source of the secure boot-related boot failures that developers who install Linux on UEFI systems without understanding secure boot encounter and cannot diagnose, because the error message that the UEFI firmware displays when it rejects an unsigned bootloader is not the error message of someone who understands what secure boot is and why it is rejecting the bootloader. The sixth thing you're doing wrong is installing Linux without a backup and recovery strategy, whose absence means that the inevitable first serious system problem, the failed update that breaks the boot, the misconfigured driver that corrupts the display stack, the package conflict that takes down a critical system component, is the problem that destroys the hours of post-installation configuration work you invested in the system, forcing the reinstall that starts the cycle over from the fresh installation rather than from the last known good state that a backup and recovery strategy would have preserved. Timeshift is the backup tool whose existence on Linux represents the difference between a system problem and a system catastrophe. A tool that creates file system snapshots, whose restoration capability means that the failed update or the misconfigured package or the experimental configuration change that broke the system can be undone in 5 minutes by restoring the snapshot taken before the change was applied, returning the system to the state it was in before the problem occurred without requiring a reinstall, without losing the configuration work that accumulated between the installation and the snapshot, without the hours of reconstruction that the reinstall requires. Install TimeShift immediately after your next Linux installation. Configure it to take daily snapshots and retain the last 7 days of snapshots, which gives you a 7-day window of system states to which you can restore if any change in that window produces a system problem. Store the snapshots on a separate partition or a separate drive from the root partition so that a root partition failure does not also destroy the snapshots whose purpose is to recover from exactly that kind of failure. Because the developer who has TimeShift configured is the developer who experiments fearlessly with system configuration, who applies updates without anxiety about what they might break, who tries the new driver version knowing that the restoration path back to the working state is 5 minutes away, and the developer who does not have TimeShift configured is the developer who is one bad update away from the reinstall that starts the cycle over. What all 6 of these wrong installation approaches share is the property of front-loading convenience at the cost of backloading pain, making the installation faster, simpler, and lower friction at the moment of installation in ways that create the problems, the reinstalls, the configuration losses, and the workflow disruptions that arrive weeks and months later as the deferred cost of the convenience that the wrong approach provided at installation time. The right installation approach is the approach that inverts this trade-off, that accepts more complexity and more time at installation in exchange for the system stability, the workflow alignment, the recovery capability, and the configuration correctness that eliminate the deferred costs that the wrong approach was postponing rather than preventing. The installation you do tonight is the foundation of the workflow you will build for the next year on top of it. The choice of distribution is the choice of the design philosophy that will either align with your workflow or fight it every day. The partitioning scheme is the structure that will either accommodate your usage patterns or constrain them at the worst moments. The desktop environment is the resource allocation decision that will either support your development tools or compete with them. The post-installation configuration is the investment that will either pay dividends across every subsequent working day or leave the productivity that Linux promises locked behind the generic substrate that the installer created. The boot configuration understanding is the knowledge that will either make system problems recoverable or make them catastrophic. The backup strategy is the safety net that will either make experimentation fearless or make every system change an anxiety-inducing risk. Stop the installation. Do it right this time. Choose the distribution whose design philosophy matches your actual workflow requirements, not the one with the most Reddit upvotes. Partition. The drive with intention, with understanding, with the knowledge of what each partition contains and how much space your actual usage patterns require. Choose the desktop environment based on the resource allocation that leaves the most headroom for your development tools, not the one that looked best in the screenshot. Plan the post-installation configuration before the installation begins, so that when the installer finishes, you know exactly what comes next rather than stopping at the point where the desktop loads. The difference is the understanding that you bring to the installation process. You now have that understanding. Stop the wrong installation, start the right one tonight. There is something that happens inside the Linux community that this warning needs to name directly because its existence is part of why the wrong installation approach persists at the scale that it does among developers who are smart enough and motivated enough to have made the decision to switch to Linux in the first place, something that is not malice and not gatekeeping in the traditional sense, but is the structural consequence of a community whose members learned Linux through the painful experience of the wrong approaches, and whose institutional memory of that learning process has normalized the wrong approaches as the necessary path rather than recognizing them as the avoidable path that better initial guidance would have allowed the next generation of Linux developers to skip. The Linux community teaches by survival. You install the wrong distribution and you reinstall. You lose the configuration in the reinstall and you rebuild it. You hit the boot failure and you learn grub to fix it. You fill the root partition and you learn partitioning to prevent it the next time. You lose the work session and you learn tmux to protect it. Every one of the wrong approaches this warning describes is an approach that the community's institutional knowledge recognizes as wrong. And the community's response to that knowledge has been to let the new user make the mistake, survive the consequence, and learn from the experience, rather than to deliver the warning before the mistake is made, and the consequence is experienced. This warning is the intervention that the community's survival-based teaching model does not provide. The 6 wrong approaches, named in this script, are the 6 most common causes of the Linux reinstall cycle that traps new developers in the pattern of installing, breaking, reinstalling, breaking again. The cycle that consumes the time and energy and enthusiasm that should be going into building the development workflow on top of a stable system, rather than repeatedly rebuilding the system itself. The developer who exits the reinstall cycle is the developer who received the right information before the installation rather than after it. The developer who chose the aligned distribution before installing rather than discovering the misalignment after weeks of working around it. Who partitioned with intention before the partition table was written rather than after the space problem revealed what the intention should have been. Who configured the backup before the first system problem rather than after the first system problem destroyed the configuration work that the backup would have saved. You are reading this before your installation. Or you are reading it after an installation that has already been made wrong and that can still be corrected. By reinstalling now, with the understanding that this warning provides, rather than waiting for the wrong installation's deferred consequences to force the reinstall at the moment of maximum damage. Either way, the reading of this warning is the moment that separates the installation you are about to do from the installation you should do. The right installation takes longer at the front end. It requires more decisions, more research, more intentionality about what each choice means for the workflow you are building on top of it. And it pays for that investment every single day that you work in the environment, whose stability, whose alignment with your workflow, whose recovery capability, and whose configuration correctness are the direct return on the time and attention you invested in doing the installation correctly. The wrong installation is faster tonight. And it costs you every day after tonight until the reinstall that the deferred consequences eventually force. Stop the wrong installation. Do the right one. Because the Linux environment that you deserve to work in is not the environment that the fast installation produces. It is the environment that the right installation produces. And the right installation starts with this warning, which you have now received. So there is nothing standing between you and the right installation except the decision to stop, to research, to plan, and to begin again with the understanding that the wrong approach never gave you the chance to have before the partition table was written and the bootloader was configured and the installation that was going to create the next reinstall was already live on your drive. Stop. Research the distribution whose philosophy matches your workflow. Plan the partition scheme whose allocation matches your usage patterns. Choose the desktop environment whose resource consumption leaves room for your development tools. Write down the post-installation configuration steps before the installation begins. Understand grub before you let the installer configure it. Install timeshift before you configure anything else, then build. Build the workflow on top of the right foundation. Build the configuration on top of the stable system. Build the habits on top of the correct tools. Build the productivity that Linux was always capable of delivering and that the wrong installation has been preventing you from reaching. The right installation is waiting, and so is everything you will build on top of it. Stop what you are doing. Start what you should be doing right now.